and I am a research associate in Imperial College London. I am part of Resilient Information System Security Group led by Professor Emil, and I work in the RESI project, which stands for Responding to Attacks and Compromise at the Edge. So what we are trying to do is to develop methods that enable Internet of Things environment to cope with attacks and continue working even after being partially compromised. Those methods basically has to answer this question, which is how to cope with the changes in threats when the environment is changed. And by that we mean when we add new additional devices to the system or remove devices or two systems brought together. To answer this question, the first step is basically to understand how attacks propagate when the environment is changed. We need to represent the attack path using something called attack graphs. We implemented our work using a graph database management system or Neo4j. All our work mainly related to attack graph. Attack graph basically is a representation of all possible attack paths that the attacker may follow in order to compromise a target. And in order to do it, we need to know information such as the topology that we have, the devices that we have in the topology, the vulnerabilities in those devices, and the condition that has to be satisfied in order to successfully compromise the vulnerabilities or to exploit them, and configurations such as firewall rules. The main problem basically is that traditional attack graph techniques cannot be used to represent threats in IoT environments. This is because IoT devices have unique characteristics. They can deploy diverse and different communication protocols and technologies, and they can be mobile. This ends up having a huge change in the environment, such as networks can be bridged together unintentionally and open opportunities for attacker to perform more attacks. We will end up having a very complex and dynamic network that looks like spaghetti, and it's hard to model its threats using traditional attack graphs. So what we can do basically is that we can transform the static attack graphs that use to represent threats in static environment that do not change and make them dynamic, meaning then that they can continuously capture the changes in threat when the environment is changed. In order to understand attack graphs, imagine that we have here a clinic. So our clinic is comprised of 3 floors where there are devices in each floor. They can be IoT devices, and they can be workstations, and they may have vulnerabilities. And they can communicate through routers which deploy firewall rules, and they can connect with the internet as well, where there is an attacker whose goal is to compromise the target. To generate the attack graph, the first thing we need to do is to model the topology of the clinic using a graph. So for example, here is our clinic topology graph. The nodes in the graph represent the devices in the clinic, and the edges represent the connectivity links, the physical connection between those devices. From the topology graph, we can generate the reachability graph, because not all the devices can reach each other. It depends on the firewall rules and other configurations. So from the reachability graph, we can generate the attack graph. So here, our attack graph shows the possible paths that the attacker may follow in order to become a user on the database. It also shows the vulnerabilities that he exploits along the way. So imagine this situation where we have a patient who is going to the clinic, and our patient, he is saying hi in order to show us his luxurious smartwatch, which is also a target for another attacker. He is also carrying a smartphone. So our patient also has a topology. So the question is what happened to the topology of the patient and the clinic when the patient goes to the clinic? He also has an attack graph. So also what happened to the attack graph when the patient goes to the clinic and goes from floor to floor and leaves the clinic? To answer those questions, our approach is to propose a dynamic attack graph. So we use Neo4j to develop multiple algorithms for ciphering queries. The first thing basically is to model the topology graph of all the network that we have, and then generate the reachability graph from the topology graph, and then generate attack graph from the reachability graph. And when a network joins another one, we have to merge the topologies of those networks by adding new edges, then regenerate the reachability graph of the merged topologies, and regenerate the attack graph. When the network leaves, we have to demerge the topology graph of them, the merged one, and then we have to remerge the attack graph. And here we will just work on our remaining challenges, such as choosing the appropriate threat mitigation technique. If you want to know more, this is our contact details. Thank you.